Let's go through LeetCode 545 boundary of binary tree. So it gives us a binary tree root, and let's return list of integer which represents the boundary. So let's look at what is the boundary. Example 1 is not straightforward. Let's look at example 2. You see the boundary. This is a boundary, right? Then it's going to its left. And trying to see this is left node. It's not a leaf, right? Then um, so then it add this part, this kind of leaves, and then what it do is that it's going to add these leaves, right? And then the right boundary. So we'll look at this question. It actually add in these kind of orders. One is the root, root, and then the nodes on its left side, right? So uh, but the on its left boundary, right? So let's think about because we have 6. This is also its that is on its right boundary. So if there is no 4, right, we should add 5 as its left boundary, right? So we need to add this kind of on the outside, right? If there is something here, right? On the left outside. So that is part 2. And part 3 will be the leaves. We'll consider its left child leaves, right? And then we add leaves, the right child leaves. And then we add the right, the nodes on the right edges, right? So we have 1, 2, 3, 4, 5 parts. So we just step by step add this one and write um that is add then to the left boundary just add the nodes. Then if its left doesn't equals no, then DFS to its left child again, right? And if its left equals none, then we DFS to its right. So, mm, and if it is none, right, or it is a leaf, we return. And for the leaf part, so if this node is none, we will return, right? If it's a leaf, it's left or right equals none, then we'll add it to our list. Then we DFS is left and DFS is right. So for the right, what we do is that if it is null, we return, right? And if it is a leaf, we return, right? We don't need to add. And then um, we try to DFS to see if it has the right, right? To write a part first. If there is a right child, then DFS is right. If it doesn't have its right, then DFS is left. So this is reverse to its the left side, right? So we can implement these logics. So let's write code for this. So we'll say list of integer results equals new array list, right? So let's have we want to add the root dot value, but if it is null, we should return, right? If root equals null, we just return result. Then we have result add root dot value, right? Then we are going to have right the left boundary root dot left. We have this result. And after So this is the second part. The third part is for the left tree, it's leaves, right? So leaves root dot left result. And then we do leaves root dot right dot result. Then we add right boundary root dot right dot result. Right. So then let's write private void left boundary. Right. So tree node and we have this integer result, right? So we'll see if this is none, node equals none, right? We should return. And if this is a leaf, right, we also need to return. Then what we do is that we should have result add this node dot value, right? So we know that left side will have high priority, right? So let's look at the if we have this side and this side, because the right side will be covered by its left, right? So we'll check if there is this node dot left exists, then DFS is left. Then we don't need to DFS this right? Um, then the thing is that if this doesn't exist, this is also the left boundary node. So we'll say if it doesn't exist, well, DFS is right. So what we write is if node dot left doesn't equal to null, we're going to have left boundary node dot left result. So we'll write else, right? Else the left boundary node dot right dot result. So this will be the part two. And about the leaf, right? So leaf will be, let's also leaf. So we're going to have tree node list integer result, right? So if it is null, we return. If node equals null, we just return, right? And let's just say if it is a leaf, if node dot left equals null, and node dot right equals null, right? Then we're going to have a result add node dot value and return, right? So the things that we DFS the trees, right? And we, for example, file, right? And we'll check whether it's left part. We'll find its left child or the leaves. Then right its right child or the leaves, right? So we'll put all of the leaves, right? Both left side and right side, because this one, the leaves will not, there is no priority of left or right. All of the leaves will be put into our result, right? So we'll write, um, we'll write leaves node dot left result, right? And also leaves dot node right dot result. And then we write its right boundary private void right boundary. So tree node list integer result. Yeah. So we'll write if this node equals none, just return. right? And if it is a leaf, we also need to return. Now the dot left equals null, and now the dot right equals to null, right? Return. Now what we do is that we want to check its right first, right? So we'll write if node dot right done equal to null, so we're going to have right boundary. We should add this kind of value to our list, right? Add node dot value, and we know that right if a tree has both left side and right side, so the right will have higher priority, right? So node dot right result. And if none exists, then we'll write else right boundary. Node dot left result. So this will be the code. Leaves, leaves. It's called leaves. Missing and return result. Three. No left. Here, this order is uh this one should be added after we do right in the left, because we'll see the left edge, right? That is we should add those kind of nodes, because we are from the root to to its left child, right? So we'll add parents first, but this one we need to add child first, right? So result add node dot value. So here we'll see, because we are from the child to root, right? It will be O(n) time complexity, because we just go through all of the boundary, right? And nodes just uh, just traverse once, and also O(n) space, right? Because we are doing the DFS. Let's also write a Python code for this. So we'll write if not root, just return empty list, and result equals root dot value, right? And we're going to have self dot left boundary root dot left, and self dot leaves root dot left, right? We can pass in the result, and we're going to have self dot leaves root dot right, and the result, and we're going to have self dot right boundary root dot right result. In the end, just return result. Then we define left boundary. So self node tree node optional, right? Because it is possible not optional tree node, and we need to have a result, which is a list of int. So if not node, just a return, right? And we'll write if not node dot left and not node dot right, but will also return. So here the order is that we're going to append this value first. So result append. Just the right edge is the reversed node dot value, and then we're going to have left boundary. Then we're going to write self dot left boundary node dot left result. Self here the things that we'll write if left, right? If node dot left done equals to null. Then we're going to self boundary is left, and we'll say if doesn't we'll write else, right? Doesn't have left child, then the right this kind of node will be the left edge, right? Left boundary of the edge, not leaves the part two, right? Else we're going to have self but the right left boundary node dot right result. So this will be the left boundary, and also we'll define leaves. So we're going to have self, and the node should be optional. Tree node, and we're going to have result should be a list of integer. So also if not node, if it's null, we need to return. And then we'll write if it is a leaf, if not node dot left and node not node dot right, then we're going to have result append node dot value and then return, right? So for the leaves, we'll do both left and right self dot leaves node dot left result and self dot leaves node dot right result. So this will be the left boundary, right? So also we need to define the right boundary. Should you have a self and the node, we are going to have optional tree node result, and the result should be a list of integer. So we'll write if not node, we're going to return right? And if not node dot left, so if this is a leave, right, and not node dot right, we also need to return, right? Because we are in the part 1, 2, 3, 4, 5, right? We just uh, put those kind of on the right edges, which is not leaf into our result. But the thing is that we are now from the leaves from the child to its parents, so we need to uh, add value last, right? So what we do is that, of course, if we have a right child, it will cover its left edge. So we'll say if node dot right, we're going to have self dot right boundary node dot right result, and we'll write else self dot right boundary node dot left result. After this one, we're going to this will be the post order. For the left edges, we're going to have pre-order, right? Then we're going to have result append node dot value.